Alright, so we're here now, and this is the last question on the paper. And this one is worth 10 marks, question number 6, part 1. It says, given that dy by dx times the tan of x plus y minus 2 cos square x equals 0, we need to prove that y is this. Okay, so to do this right here now, first thing we have to look at it and say that it's a first order differential equation. So let's just break this up here. So that's a first order differential equation. So let's just rewrite it. This is now dy by dx times tan x plus y equal to, bring over the 2 cos square x over this side. This is now 2 cos square x over here. Now remember that tan x is sine over cos. This is saying dy by dx times sine x over cos x plus y is equal to 2 cos square x. So we can divide through by sine x over cos x. So if we divide through by sine x over cos x, this is going to become dy by dx. Now right here, so now becomes 1 over sine x over cos x. That becomes plus cos x over sine x times y, and that's equal to now 2 cos square x divided by cos x divided by sine x over cos x. This is going to become 2 cos square x divided by sine x over cos x. That is going to become 2 cos cube x over sine x. That's what we're going to get. Alright, if that is not clear, let me do the division. See it here, 2 cos square x divided by sine x over cos x. When you divide, you change it to multiplication and flip it. That's cos x over sine x. Cos x times cos square give you cos cube over the sine x. So that's how we end up get this here. So that's what we get right there. And so from this now, it's in our standard form, so now we can find our integrating factor. So our integrating factor is e to the integral of whatever is being multiplied by y. So it's the integral of cos x over sine x dx. Now we integrate that, we get e to the derivative of sine is cos, so it's e to the ln sine x. And e to the ln of sine x is just sine x. So therefore, the general solution, we know it is y times the integrating factor equal to the integral of the function of x times the integrating factor dx. So this becomes y sine x is equal to the integral of the function of x we have is this, 2 cos cube x over sine x times sine x. 2 cos cube x over sine x times sine x. So now sine x times sine x cancel each other. And so what we get is y sine x is equal to the integral of 2 cos cube x dx. Because this sine x cancel this sine x. Alright, so y sine x is the integral of 2 cos cube x dx. Now, right here, so now is a whole different ball game. So we're going to take off this side to integrate 2 cos cube x. So let's take off this side. So now we end up with y sine x is equal to the integral of 2 cos cube x dx. Now if this is what we have, we can break up this as factor out the 2 times the integral of cos cube x dx, and then we can rewrite this as 2 times the integral of cos square x times cos x dx, and then cos square x, remember, is 1 minus sine squared. So this becomes 2 times the integral of 1 minus sine square x times cos x dx. So that is y sine x. Now what we're going to do is take off this part here. What we're going to do now is use a u substitution. So we're going to substitute in u. So we're going to let, right here, let's put it here, let u equal to sine x, and so du is cos x dx. Because if we substitute u as sine x and du as cos x dx, this becomes equal to 2 times the integral of 1 minus sine x is u, so that's u squared, cos x dx is du, that's y sine x. So after we do that now, what we end up getting is this work out to be equal to, so just to finish it off in this box right here, y sine x work out to be equal to 2 times, when you integrate 1 you get u minus u cubed over 3 plus some constant k. So y sine x is equal to 2u minus 2u cubed over 3 plus k. That's what we get. That's y sine x. But remember, u is sine x. Since u is sine x, this is saying y sine x is equal to 2 sine x minus 2 sine cube x over 3 plus k. That's what we end up get. Y sine x. Now right here, so now we can divide through by sine x. And by dividing through by sine x, we're going to end up get y is equal to sine x over sine x gone, that's 2 minus, when you divide out sine, take out a sine out of sine cube, left sine square, that's 2 sine square x over 3 plus k over sine x. That's what we end up get. So now so far, we're probably going like 7 out of the 10 marks. Let's take off this side and continue. So that's how many steps you'd have had to be going and going and going. So take off this side now. We're almost finished. So right here, so now we have y is equal to, you see this 2 here, so I'm going to rewrite 2 as 6 over 3. You probably wonder why, because remember, this is what we're trying to prove. So this 2, rewrite 2 as 6 over 3. Then this becomes minus 2 over 3 sine square x plus, you see what constant over sine x? Remember, 1 over sine x is cosec. So that becomes plus k cosec x. Alright? So I'm just going to take off this. And then now what do we need to remember? What we need to remember is, remember this. Remember that 1 minus 2 sine square x is equal to cos 2x. So if we make sine square the subject, sine square x would be equal to 1 minus cos 2x over 2. That would be sine square x. Let's make sine square x the subject from that. So therefore, y is equal to 6 over 3 minus 2 over 3 times sine square x is 1 minus cos 2x over 2 plus k cosec x or c cosec x. I change the constant from k to c just to match up with what they have here. And then guess what happened? So this 2 cancel out this 2. So end up get y is equal to 6 over 3 minus, this becomes 1 over 3 times 1 minus, minus and minus become plus, that's now plus 1 over 3 cos 2x plus c cosec x. Now 6 over 3 minus 1 over 3, That's 5 over 3. So y is 5 over 3. 6 over 3 minus 1 over 3 is 5 over 3. Plus 1 over 3 cos 2x plus c cosec 2x. That's the answer. Alright? If you get this, you're general. 10 marks. I do that proof you get this, you're general. I just give them the general look. Yeah man, if you get this, you're general. So that's not easy. 10 marks. Oh, most people got it. Now. The next part tells us that determine the particular solution when y, so this is part 2, they tell us that y pi of 2 equals 0. So what that means is, remember our equation is y is equal to 5 over 3 plus 1 over 3 cos 2x plus c cosec x. And then they're telling us when x equal pi by 2, they're telling us that y is 0. So 0 is equal to 5 over 3 plus 1 over 3 times the cos of pi, 2 times pi by 2. 2 times pi by 2 is pi. So that becomes the cos of pi plus c times cosec x. Remember that cosec is 1 over sine, so it's really c over the sine of pi by 2. The sine of pi by 2 is 1, so that becomes 0 is equal to 5 over 3. The cos of pi is negative 1, so that's minus 1 over 3, plus c over 1. Make c the subject, so we need to bring these over here. 5 minus 1 is 4, so that's 4 over 3. That's minus c, so therefore c equal negative 4 over 3. So therefore, the general solution or the specific solution in this case is y is equal to 5 over 3 plus 1 over 3 cos 2x. C is 4 over 3, so minus 4 over 3 cosec x. That's the answer. This is a 3 marks. That's it right here. That's part 2. Y equals 5 over 3 plus 1 over 3 cos 2x minus 4 over 3 cosec 2x. And that's it. Nothing much to it really. Nice. Part B says determine the general solution of this differential equation y double prime plus 2y prime plus 5y equals 0. So in order to determine the general solution of a second order differential equation, what we have to do is we have to write the auxiliary equation for this. So we have to write the auxiliary equation, or some people might say we have to solve the characteristic equation. So the characteristic equation is going to be given by u squared plus 2u plus 5 equals 0. So solving for u, using the quadratic formula, it's minus b plus or minus the square root of b squared minus 4 times a times c divided by 2 times a. So u is equal to minus 2 plus or minus 2 squared is 4. 4 minus 20 is negative 16, so that's minus 16 over 2. So u equal to minus 2 plus or minus, this is the square root of 16 times the square root of negative 1 over 2. The square root of negative 1 is I. So u going to be equal to minus 2 plus or minus, square root of 16 is 4. That's 4i over 2. That is, divide both of them by 2 now, that's negative 1 plus or minus 2i. So since that is the solution for u, we end up getting u is equal to minus 1 plus 2i, or u equal to minus 1 minus 2i. So therefore, the general solution then is y is equal to, now anytime it is in this form, it is e to the minus x in bracket a cos 2x plus b sine 2x. That's your general solution. And why it is like this is because the roots are complex. Whenever the roots are complex, this is the form that it will take. So this is the general solution. Why is this? And they give 7 marks for that. Easy. Don't be afraid to tell them easy. So that's easy. We get 7 easy marks. That's that. 7 easy marks. The final part says, hence determine the solution of the boundary value problem with. So now they're telling us that, this is for part 2, they're telling us that y of 0 equal to 1 and y of pi equal to 2. So let me just take off here. We need to find solve the boundary value problem. Y of 0 equal to 1. Alright, so let's take that down right here. So we have y, remember y is what we just found, e to the minus x in bracket 2 a cos 2x plus b sine 2x. Now only thing we're going to do is substitute in the values for x and y. So when x is 0, y is 1. So when x equals 0, y equals 1. So that should give us a value for a or b. When x is 0, 1 is equal to e to the 0 is 1 times the cos of 0 is 1. So that leaves a plus the sine of 0 is 0. So that's 0. And so that means that a equals 1. Okay, a equals 1. Now let's look at the next part. When x equals pi, it's a y equals 2. When x is pi, we put pi in here. So 2 is equal to e to the minus pi. X is pi. Now, this is 2 times pi. The cos of 2 pi is the cos of 360. What's the cos of 360? Cos of 2 pi, it's really solid job for the calculator. The cos of 2 pi is 1. So this is a. But then the sine of pi is 0. So this is saying that 2 is equal to ae to the minus pi. And so if we divide by e to the minus pi, divide by e to the minus pi, this is giving us a is equal to 2 over e to the minus pi. Now look at this. This is saying a equal to 1, and this is saying a equal to 2 over e to the minus pi. Now what is e to the minus pi? E raised to the minus pi is 0 point something. 2 divided by that is 46. Now a can't be 1 and a can't be this. So what we're going to say here is a equal 1 and a equal 2 over e to the minus pi. Therefore, this is not possible. This is not possible. And so therefore, this boundary value problem has no solution. This boundary value problem, BVP mean boundary value problem, has no specific solution. This has no specific solution. We cannot solve for A and B. We cannot solve for A and B. So This has no specific solution. That gives you 5 marks. We cannot solve it. Can you get a equal 1 and a equal 2 over e to the minus 5? A cannot be 2 value. A cannot be 2 value. I don't even get a value for b. So this has no solution. This boundary value problem has no specific solution. The solution is just y equal e to the minus x, a equals 2x plus b sine 2x. This don't make it have no specific solution. So this have no solution. And that's it. I really hope this was good. Alright, so yeah, I really hope the paper was good. Stay tuned for more. Alright, stay tuned for more, and keep on practicing, keep on prepping for unit 2. If you're doing it next year, keep on prepping. If you're just watching this video to review how the paper went for you, no worries, I hope it went well. And until then, see you next time.